In the topic thermodynamics, till now we have discussed the concept of different thermodynamic potentials. Now we will use these concepts of thermodynamic potentials in developing the theory of phase transition. So in this first lecture, we will see something just as an introduction regarding phase transition. That is, what is phase transition, how many types of phase transition is, and some important facts. And after this introductory lecture, we will actually start this topic. So, first of all, we should note that the phase transition is actually a most interesting problems in equilibrium statistical thermodynamics. As you know, matters usually exist in three physical states, or you may say in three phases, and that three phases are simply solids, liquids, and gases. So three phases in which the matters exist in general. Three phases. Phases means here physical states of matters. These are in fact solids, liquids, and gases. As we know, these liquids and gases are combinedly called fluids. When you say fluid, it means both liquids and gases. So we may classify these as solids and fluids. Fluids is in fact the common name for liquids and gases. So, in general, we may say the three phases of matters or two phases of matters are solids and fluids, and when you say three phases, that will be solids, liquids, and gases. Liquids and gases are commonly called fluids. Now we will see some of the important properties in very nutshell of these two forms of the matters. First of all, solids. We know the different characteristic of solids from very lower classes. First of all, when we discuss the characteristics of solids, what we will see? We see that these have definite shape and volume. You may say size or volume. Apart from this, it is a rigid structure. A rigid structure. Intermolecular arrangement are in fact ordered, or a particular shape, you may say. So the another characteristic is ordered arrangement of atoms or molecules. Atoms or molecules. This material sustains shearing stress. Sustain shearing stress. So modulus of rigidity is defined for this, and you point out an important property of this material, which is actually the solids gave sharp Bragg reflection in a diffraction experiment. You may say solids give sharp Bragg reflection in a diffraction experiment. So these are some specific properties of solids. Now we will list some specific properties of fluids. As I have told you, when you say fluid, it means you are talking about both liquids and gases. So the important properties of fluids. When we talk about fluid, first of all, just you may say that it has no definite shape, no definite shape. Volume of liquid although fixed, but that of gas is not fixed, and fluid do not sustain shearing stress. Do not sustain shearing stress, and the molecular or atomic arrangement is no long ordered. So no long range order, no long range order atomic or molecular arrangement. So these are some important characteristics of fluids. Now we will talk about the phase transitions of these physical states of matter first, and then we will see that the phase transition does not mean only change in physical state. It is something different too. So in general, phase transitions are the transitions of a matter from one phase to another, and remember, both of these phases coexist with one another. Whenever there is phase transition, the matter in second phase coexists with the matter in first phase, and in such a transition, actually there is a change in mutual arrangement of molecules and also in the thermodynamic properties of the system. So whenever a phase transition takes place, see here, I am writing just it in symbolically. Let us suppose any matter is in phase 1. Phase 1 means state 1, and this state is changed into the second state or second phase. This is say phase 2. As I have told you, both of these phases coexist simultaneously. That is, phase 2 exists with phase 1 during the phase transition, and in this phase transition there is a change in the mutual arrangement of atoms or molecules, and also thermodynamic property. So what is the important facts regarding it? Both phases coexist. Another, there is a change in arrangement of atoms and molecules. Whenever a phase transition will take place, there will be a change in atomic arrangement or molecular arrangement, and a change in thermodynamical properties may take place. These are some specific feature of a phase transition. Now, when a phase transition takes place, then there are three phase transition points of interest. And what are these phase transition points? So the phase transition points, let us see. Phase transition points. Actually, these phase transition points are classified as: number 1, melting point. In short, we call it MP. Actually, melting point is the phase transition point of solid-liquid phase transition. When a solid changes into liquid, then we call the temperature at which this transition takes place, that is called melting point of the solid. So it is solid-liquid phase transition point. I am writing it in brief. It is solid liquid phase transition point. The another phase transition point is called boiling point. This is called boiling point. In brief, we call it PP, and it is the liquid vapor phase transition point. This is liquid vapor phase transition point. Liquid vapor phase transition point. And the third one is known as sublimation point. Sublimation point. And this point is defined when a solid is converted into a vapor. So it is actually solid vapor phase transition point. This is solid vapor phase transition point. Phase transition point. Now, we all are familiar with boiling of water, melting of ice, and transition of a gas into liquid under a compression. These are the common examples with which we all are familiar with. Actually, all these examples are examples of phase transitions, and these types of phase transitions are such a phase transition in which the transition of physical state of the matters takes place. But apart from these type of phase transitions, there are also phase transitions in which there is no transition of physical state, but there is a transition of thermodynamic properties. For example, you may say transition of a ferromagnetic state to a paramagnetic state at a particular temperature, which is called Curie point, denoted by Tc, is example of such a phase transition. Similarly, we may take another example. You will study in the forthcoming lecture of physics at low temperature that there is a transition of liquid helium-1 to a liquid helium-2 at a particular temperature that is called lambda transition temperature, T lambda. So, these are some examples in which there is a phase transition but not a transition of physical state. In such phase transitions, there is a transition of only thermodynamic properties. So, we may understand that during a phase transition, there is either a transition of physical state or a transition of thermodynamic properties. And both of these types of transitions are under phase transitions. We will see, in fact, both types of phase transitions after this introductory lecture separately. So, I just write in very brief, which I have told you just now. So, phase transitions like transition of solid into liquid, liquid into vapor, or gas, or gas into liquid. These are some common examples. So during a phase transition, number one, either transition of physical states, Just for example, as I have told you, a solid may change into liquid, a liquid may change into vapor, and vapor may change into liquid, and liquid may change into solid. These are some examples of such a phase transition. But there are also phase transitions in which such type of transition of physical state does not take place, but in those transitions there is a transition of thermodynamic properties. Transition of thermodynamic properties. Transition of thermodynamic properties. For example, as I have told you, transition of ferromagnets to paramagnets at Curie temperature. This is noted by TC. Another example is transition of helium first, liquid helium first to liquid helium second. Liquid helium first to liquid helium second at lambda transition temperature. Lambda transition temperature, and this temperature is denoted by T lambda. So in such transitions there is no change in physical state, only there is a change in thermodynamic properties. Now a phase transition is represented on a indicated diagram, and that diagram is actually the relation, that diagram actually depicts the relation between P, V and T. We may show this transition either on a PT diagram or in a PV diagram. So when we show a phase transition on PT diagram, one thing you must remember, a phase transition always takes place at a particular temperature and pressure. So a phase transition is also called a isobaric isothermal process. So in this case, let us see in this figure, when we plot a graph between the parameters P and T, that is P is plotted in against of T, then the phase transition curves are like this. Say it is point O, this is A, and this is a particular point called C. Here, this region indicates the solid state. This refers liquid state, and this refers gaseous state. In this PT diagram, what important things we can understand from this diagram, let us see. Actually, in this figure, let us say this is figure A. In this figure, the line OA, this line OA represents sublimation boundary or sublimation curve. You see, actually this represents, this OA is not sublimation boundary, but this is melting boundary, because this is between solid and liquid. So in this figure, what is OA? OA represents melting curve or melting boundary. Melting boundary. And this OB you see here, this separate the state solid and gas. So this is in fact called sublimation boundary. This is sublimation boundary. And OC, this separates liquid and gaseous phases, and so it is called boiling boundary, and normally we call it saturation boundary. OC is boiling boundary, and popularly it is called saturation boundary. Saturation boundary. Saturation boundary. Actually, this curve OC terminates at a particular point C, and that point C is actually called the critical point. That point C is called critical point. So in this figure, point C is called critical point. This is called critical point. So you may say, what is critical point? C. Actually, this critical point is the point where saturation line or saturation curve gets terminated. It is the point where the saturation curve gets terminated. And see this point O, where all these three curves meet together. It means O is the point where the three phases exist simultaneously, or there is a coexistence of three states of the matter. And this particular point O is known as the triple point. It is called triple point. So we may define triple point as the point where all the three states of matter coexist in equilibrium. And one thing we should note here, that there are some substances which have more than one phase in solid state. In case of such substances, there are more than one triple point, not a unique triple point. If the materials have different phases in solid states, so corresponding to that material there may be more than one triple point. But if a material has only one physical state or only one phase in solid state, then that will have only one triple point. So I am just writing the important point, triple point O. triple point O. How I have defined it? I have defined that it is the point, where all three states, where all the three states of matter coexist. All the three states of matter coexist in equilibrium. Coexist in equilibrium. Coexist in equilibrium. For example, in case of water or solid, this critical point Tc corresponds to the temperature 273.16 Kelvin, and at this temperature there is a coexistence of solid ice, liquid water and gaseous vapor. All these three phases exist in equilibrium simultaneously. They have a coexistence. This phase transition may be seen on a diagram that is called PV diagram, but till now I am not considering this PV diagram. In forthcoming lecture I will discuss it. I have just mentioned only one diagram, that is PT diagram, but all these things can be understood on PV diagram too, which I am just omitting here, but it will come into our discussion in after a very short time. So now we will classify the phase transition, or you may say classification of phase transition. Classification of phase transition. In a broad sense, phase transitions are classified as: number 1, first order phase transition. First order phase transition, and number 2, second order phase transition. First order phase transition and second order phase transition. Now, first order phase transition. What are the important characteristics? First order phase transition. What are the important characteristics of this first order phase transition? So, first of all, we note an example. When you say first order phase transition, it means change of physical states. That is, the transition of solid into liquid, or liquid into gas, gas into vapor, or vapor in gas into liquid, or liquid into gas. These are the common examples of first order phase transition. And actually, in a first order phase transition, what takes place? What takes place? So we note down the important characteristics of first order phase transition, that whenever this type of phase transition takes place, definitely heat energy is either evolved or absorbed. In other words, you may say that first order phase transition always takes place at the cost of heat energy. So, heat energy is, in case of first order phase transition, heat energy is either absorbed or evolved. Or as I have told you, you may say that this phase transition takes place at the cost of heat energy. The another important characteristic of first order phase transition is that in this case there is a discontinuous change of internal energy and a specific volume. A specific volume, what do you mean by a specific volume? As I have told you before, that a specific volume is the volume of unit mass. So internal energy and the specific volume of our matter, of our substance, get changed discontinuously, in a discontinuous manner. So the another important property is discontinuous change in internal energy and a specific volume of the substance. And as I have told you, the common example of such a phase transitions are what? Transition of solid into liquid and transition of liquid into solid, transition of liquid into vapor, and vapor into liquid. These are its common examples. Now, the second order phase transition. Second order phase transition. As I have told you, in a phase transition, there may or may not be a transition of physical state. And when there is no change in physical state but there is a change in thermodynamic property, then such a phase transition is called second order phase transition. So in this phase transition, no heat energy is absorbed or evolved. So its main characteristics are: number one, no heat energy is evolved or absorbed. Or you may say this phase transition does not take place at the cost of heat energy. So now the another important property is just reverse of all the conditions are just reverse of the first order phase transition. As you have said, in case of first order phase transition, there is a discontinuous change in internal energy and a specific volume. But in case of a second order phase transition, there is a continuous or a smooth change in internal energy and a specific volume. So there is a continuous or a smooth change in internal energy. IE is for internal energy and a specific volume. And the example of this second order phase transitions are all those examples in which there is no change in physical state but there is a change in thermodynamic properties. As I have told you before, that the transition of liquid helium 1, in example you may take liquid helium 1 when transit to liquid helium 2, this is an example of second order phase transition. Or you may say the ferro transition of ferromagnets to paramagnets at a temperature called Curie's temperature. This is a common example of second order phase transition. Apart from this, there is an ordered disordered transition in binary alloys. Yes, these are examples of second order phase transition. So these are some introductory facts regarding the phase transition. As I have told you, after this introductory lecture, we will actually study this topic, that is phase transition,